provide diagrams that go along with electron configuration, scientists have come up with orbital notation. This shows how electrons will spread out within an orbital group given the opportunity, and it also shows that electrons like to pair up with opposite spins. This gets known as Hund's rule and the Pauli principle, respectively. So if you draw the electron configuration out, say for lithium, 1s2, 2s1, we can apply orbital notation to this to give it a diagram that goes with it, where each orbital gets a box with electrons paired up with opposite spins. There's our 1s2 orbital. Notice that the up arrow and the down arrow imply that the electrons are there with opposite spins, and then one bonding electron for that 2s1 orbital. That is the electron configuration with orbital notation for lithium. The Pauli principle states that electrons like to pair in opposite spins. Usually in terms of testing, it means if you see up, up, or down, down, you have violated the Pauli principle. Let's try carbon. 1s2, 2s2, 2p2. Notice we're 6 electrons in following the Aufbau order. If you learn to use the periodic table to read this, you'll be much better off. Let's apply the orbital notation just like we did for lithium. Then the 2s orbital gets paired up, and the 2p orbital, since the 2p group can hold up to 6 electrons, draw all 3 orbitals and then spread them out. This would be doing it incorrectly. We have violated Hund's rule. This would be done correctly. Ironically, carbon tends to form 4 bonds, but this implies that it would only form 2. After all, the unpaired electrons are the bonding electrons. And we'd have to go even one step further for this unusual system of describing where electrons are to show that we have, in fact, 4 bonding electrons. Keep in mind that electron dot structure gets it right to begin with. In any event, this would be the electron configuration with orbital notation for carbon. For those of you who are aware, you'd need to hybridize those orbitals into equivalent sp3 orbitals to get the actual bonding behavior correct for this system. But there it is. Let's go all the way out to sulfur with 16. Take a look at a periodic table and you'll see that the electron configuration is 1s2, 2s2, 2p6, 3s2, 3p4, 2, 4, 10, 12. That's our 16 electrons. Are they all opposite spins? They are. Do we have 3 orbital groups for the p electron group? We do. Are they spread out? In fact, they are. If we have 4 electrons going into 3 orbitals, somebody's got to get paired up. And this correctly predicts that sulfur often forms 2 bonds. Since there's d electrons available that are unoccupied, once you get to the 3rd shell, it gets a little more complicated than that. But that is the electron configuration with orbital notation for sulfur. Hund's rule says electrons spread out within orbital groups.